Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And as always, take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Edna by Jean, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have super fuzzy arrows, where we need to place a single circle on each line. Oops. A single circle on each line. And digits on either side of the circle sum to the digit in the circle. So it could be anywhere on this line. So it could be here, here, or here. And the other digits on either side of the line sum to the digit in the circle. So, for example, if we did have a circle, we placed a circle here, all of these digits on one side of the line must add up to it, which obviously is going to be problematic. So, but that's how these super fuzzy arrows work. We also have x sums, where clues outside the grid give the sum of the first x digits from the clue, where x is the first digit from the clue. So, for example, for this clue here, this would have to be the x. So we could have something like 5 here. And then this could be 2, 6, 4, and 3. And that would satisfy that because the first 5 digits here, which x is 5, add up to 20. 5 plus 2 plus 6 plus 4 plus 3 is 20. Right? They all average around 4. 4 times 5 is 20. So that's an example of how x sums works. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so let's do this one. Can the circles ever be at the end? The answer is no, because 4 unique digits would add up to what that digit is. Can it ever be in one of these two spots? The answer, again, is no. Because if you had a circle here, then on this side, this digit must sum to the same digit as that. But it can't be the same digit because they are in the same box. Same with this one, right? This digit would sum up to what that digit is, and it can't work. So on this line, the circle has to be there. And this digit has 4 other digits which are smaller than it. So it must be at least 5. Because these 2 digits add up to that, and these 2 digits add up to that. So where else can circles be? Well, to add up to 10 here, we don't have 1, 2, 3, 4 available. So it's either 2 digits, so this is 2 and 8, or it's 3 digits here. You can't have a 1 ever as an x sum unless the sum is going to be a 1, right? Because the sum of the first digit in where 1 is the first digit is 1. So this is 2 or 3. This, to add up to 11, is also 2 or 3 as x for the x sum. You can't have 4 because 4 digits with 4 as one of them can never add up to 11. To have 4 digits adding up to 11 that are unique, it must be 1, 2, 3, and 5. Notice there's no 4 there. So this is also 2 or 3. So this 5, this digit here, has a definite 2 or 3 that's smaller than it, so it cannot be 5. So this is either going to be 6 with 1, 5, and 2, 4 there. This digit, again, cannot be 1. To add up to 12, it's either going to be 2, 3, or 4 digits. Right? 2 doesn't work. It has to be 3 or 4. 2 digits would be 2 and 2 and 10, trying to add up to 12. So this is 3 or 4 digits here. Hmm. So either this is 2 and 8, or this has to be 3 and 6 with 1, adding up to 10. So this is 6 or 8 here, right? If we have 2 and 8 here, then this has to be 3 and 5 here, adding up to 8. But the problem with that is 3 and 5 plus 2 other digit. 3, 5, I guess it'd be 4. So that does kind of work. Okay, so 2 and 8. Can this be 3 is the question. If we have 3 here, to add up to 10, it would have to be 6 and 1. But 1 plus 3 or 4 is not adding up to 6, so this can't be 3. This must be 2 here, and 8. And this has to be 3 and 5 to add up to 8 here. That leaves us as 1 and 7. And 3 digits adding up to 12 is 3, 5, and 4. 2 forces this to be a 3 here. So 3 in the corner. We celebrate because, well, we're getting close to solving it. This has to be 6, 9 remaining in box 1. 11 minus 3 is 8. So it's either 1, 7 or 2, 6 here, adding up to 11. Okay. To add up to 20, you could have 4 digits or 5 digits. You cannot have 6 or more because 6 digits at minimum adds up to 21. 1, 2, 3, 4, 5, 6. So it's 4, 5 here. Remaining digits in row 3. We have 1, 2, 6, 7, 8, and 9. Column 1, we have 1, 2, 4, 5, and 7, 8. Column 2, we have 1, 3, 4, 6, or 7, 9. And column 3, we have 2, 3, 5, 6, or 8, 9. Interesting. So 4 cannot be the middle digit here. 4 is never going to be the sum of 3 unique digits. You have to have at least, because if you have 4, so this cannot be the center. This cannot be the circle, I should say. So it has to add up with the other digits to add up to a single digit. Well, if we have 4 plus 1, 2, 3, that already adds up to 10. So the circle cannot be on this side, which means the circle has to be on this side and probably here. Cannot be here because then these two digits are the same sum, are the same digit. Cannot be here because this is going to be 1, 2 at minimum here. Actually, it's 1, 3 at minimum. That's 4 plus 4 plus 1, 2 at minimum. Here is already 11. It's too big. So we have to have 4, 1, and 2 here, because otherwise this is not going to add up to a valid sum. And then this is 1 or 2 here. This that 1, 2 pair eliminates 1 and 2 in the rest of the row. So this is 6, 7, 8, 9. 6 and 7 plus 1 and 2 add up to 8, which adds up with a 3 to add up to 11. It must be 4, 1, 2. That's 7, plus 1 would add up to 8, but this can't be 8 because of 8 in the column. So this must be 2, adding up to 9. That eliminates 9 in the rest of the column, 2 in the rest of the row, 9 in the rest of the box. So these add up to 9. It's either 1, 8, 2, 7, 3, 6, or 4, 5. So any of those work, actually. Okay. Can you have this digit here be at the end? No. So this cannot be circle because these 4 digits are all unique, and that would be then all 5 of these digits would have to add up to that digit. So that's going to be at least 10. Can we have the circle there? No, these would have to be the same digit, so that's not going to work. Can we have the digit here? So the circle either is going to have to be here or here on this line. We're not sure which. So one thing is this cannot be 9 here. Um, Because 9 plus another digit can never add up to a single digit. Uh, so if it's adding up to this, you could have 6, 1 adding up to 7. Cannot have 6 and 2 here. You could have 7, 1 adding up to 8, or 8, 1 adding up to 9. But this could also be 3, 6 and 3 adding up to 9 there. If it's all 3 of these, then you would have to have 6, 1, and 2 adding up to 9 there. Interesting. Hmm. Um. Hmm. Not sure. I guess we don't have to put. No. Let's put the red for where the circle is, or where the circle could be. Could be one of those two. If this is 7, we don't have a 2 here at all. This cannot be 4 and 5 adding up to 9 because this doesn't have a 4 here. Or sorry, that would eliminate all possibilities for this cell. Okay, so we need to use the x sums. So 2 and 8 add up to 10, 3, 1, and 7, or 3, 2, and 6 add up to 11. Can we have 5 anymore here with the 9? And the answer is no. 5, 9 is 14 already. The other 3 digits would have to add up to 6. 20 minus 14 is 6. And then we have a 2 here, so this cannot be 1, 2, 3. So this must be 4 digits here, which eliminates 4 in the rest of the column and box. So this adds up to 13. The remaining 2 digits must add up to 20 minus 13, which is 7. So no 8 here, no 5 here. It's 3 or 6 here. So correspondingly, that's 6 and 1, or 3 and 4. That doesn't work with 3 and 4 because we have 4 already in the row. So this must be 6 and 1. That means this cannot be 1 here. It's 3. So these two must add up to that digit there. And it has to be 6 and 3 adding up to 9. So that's 9 there. No more 9 there. 1 and 9 is 10. 4 and 6 is 10. This can no longer be 3 and 6 as a pair. That 6 eliminates 6 in the rest of the box and column. These 3 digits add up to 9. Remaining digits we have are what? 5, 7, and 8. 7 and 8 don't work because 2 unique digits at least add up to 3, which is 1 and 2, which doesn't add up to 9. So this must be 5 here. That eliminates 5 in the rest of the row, so this must be a 1, 3 pair. This can't be 3 because of 3 in the box. So that's 1, that's 3 there, adding up to 9. 1 eliminates 1 here, so it's 7 and 2, adding up to 9. That eliminates 2 and 7 in the rest of the box and columns. 3 eliminates 3 here. We have a 1, 5, 8 triplet in this left central box, which eliminates 1, 5, and 8 in the rest of the box. So that leaves that as 3. That eliminates 3 in the rest of the column. So this is 1, 4, 6 as a triplet, which eliminates 1, 4, and 6 in the rest of the box. Okay. 6 eliminates 6 here, so this is 7 and 1. 7 eliminates 7 here, so it's 8 and 7. No more 6s and 7s there. Okay, where's 2 in box 6? Can't be here because of 2 in the row, so 2 has to be there. That leaves the remaining digits as 4, 6, and 7. No 6 here because of 6 in the column. No 7 here because of 7 in the column. Remaining digits, 1 eliminates 1 here. So this is 5 and 8 as a pair, which eliminates 5 and 8 in the rest of the box. So no 5, 8 here, it's 1. Remaining digits now in row 6 are 5, 8, 9. In row 5 are 4 and 6. 1 eliminates 1 here, so that's 2 and 1. Okay. Remaining digits of column 9. We have 4, 5, 6, and 9 with a 5 and 9 guaranteed there. 1 eliminates 1 here, so that's 7 and 1 there. Can this be a singleton here? Can this be the circle? The answer is no. Because these two digits at minimum are 3 and 5, adding up to 8, which this cannot be. These digits have to be 3 through 9. Well, can these 3 digits ever add up to a singleton here? And obviously, so this can't be the circle. We can't have a circle here because these at minimum add up to 3, 4, which is 7, plus 3, which is 10 already. So that's too big. So this can't be the circle, which means this has to be the circle there. So that's a sum of these 3 digits. And the minimum here is 1, 3, and 5. So this must be 1, 3, and 5, adding up to 9, which is a singleton digit. This cannot be 1, 8, 2, 7, or 4, 5. It's 3, 6 as a pair. This can't be 3 because of 3 in the row, so that's 6 and 3 there. That eliminates 6 here, so this is 4 and 6. So that leaves the remaining digits in column 4 as 7, 8, and 9. 7 and 8 eliminate 7 and 8 in the row there, so this is 9. That makes it 6 and 9 there. No 9 here, no 9 there. 3 and 9 eliminate 3 and 9 in the rest of the column. 9 can no longer be here because of 9 in the row. 6 eliminates 6 here. 5 eliminates 5 here, so this is 8 and 9 pair. In column 6. 1 eliminates 1 here and 1 here. All the x sums are done. 2 and 8 add up to 10. 3, 1, 7 adds up to 11. 3, 5, 4 adds up to 12. 4, 9, 6, 1 adds up to 20. 1 and 7 add up to 8. 3 and 5 add up to 8. 4, 2, 1, 2 adds up to 9. 7, 2 adds up to 9. 5, 1, 3 adds up to 9. 6 and 3 add up to 9. 5, 1, 3, 5, 3, 1 add up to 9. 3 and 6 add up to 9. So now we just have to figure this out. Okay, remaining digits. Let's do column 6, I guess. Oh, 9 eliminates 9 here, so this is 8 and 9. 8 eliminates 8 here, so it's 7. 8 eliminates 8 here, so it's 9 and 8. 7 eliminates 7 here, so it's 8. Remaining digits in box 2, we have 3, 4, 5, 6. No 6 here. No 3 here. No 3 here. Where's the 3 in this box? It has to be here. 6 eliminates 6 here, so where's a 6 in this box? It has to be there. Remaining digits of row 1, we have 4, 5, and 8. No 5 here because of 5 in the column. Row 2 has to be 4, 5, and 2. Again, no 5 there. Okay. Remaining digits of column 5, we have 2, 4, 5, and 9 as possibilities. No 9 here because of 9 in the row. Column 6, we have 1, 4, 5, 7 as possibilities. No 1 here because of 1 in the row. Okay. Row 7. 6 eliminates 6 here. Okay, so that's good. So it's 4 and 6. That eliminates 4 in the rest of the row here. No 6 here. So 6 in row 8 has to be one of those two. Remaining 4 eliminates 4 here. So remaining digits of row 7. We have 1, 2, 5, 7, 8, and 9. This can't be 1, 5, or 9 because of 1, 5, or 9 in the column. This can't be 5 or 9 because 5 or 9 is guaranteed to be one of these 3 digits here. Okay. Can this be the circle? Minimum would be 4, 2, 4, 2, which is already 12. So no, this can't be the circle. Can this be the circle? Minimum is 2, 4, 2, 1, which is 9, but this can't be 9. So that can't be circle. Can this be circle? 4, 2, 1 could add up to 7. And 7 and 1 works. Or 4... I guess it could be 1, 2, 5, adding up to that. Can this be circle? 2, 4, 2, 4 is 12. No. So this could be potentially circle. This can't be circle. These would be the same digit. So the circle has to be one of these two. So if the circle's here, it has to be 7. And this would be 1, 2, and 4 adding up to it. Right? Because this can't be 7 here, obviously, if this is 7. Can't be 4 or 5, because these are going to be more than 4 or 5 adding up. So that would be 4. You'd have 1 and 2 as a pair there. So that could work. So either 7's here, so this would add up to 7. This can never be 9, because if that were 9, 9 plus another digit is never adding up to another digit. So this can't be 7 either. Yeah, it can't be 7. So where's 9 in column 5? It has to be here. That means this can't be 9 here. It's 5. That eliminates 5 in the rest of the row. So no 5 here, no 5 here, no 5 remaining here and here. Okay. This can never be 7 or 8. 7 or 8 plus a minimum of 4 adds up to 11 at least, which is not a single digit. If this were 7, does this add up to for these 2 digits? Can't be 3 digits here with 7 and 1 and 4 at least, adding up to 12. So, can it be adding up to 7 here? The answer is no. We have 1, 4 adding up to 5, 2, 4 adding up to 6, 1, 7 adding up to 8, and 2, 7 adding up to 9. This cannot be 7. If this were 7 here. So either this is 8, which makes this 1, 7, and this is 1, 2, 5 adding up to it. Or 717. Right, so either this is 8 with 1 7 adding up to it. Or, so this can never be 2 4, it can never be 2 7. You can't have 2 and 8 here as a 3-digit sum adding up to a single digit, so this is guaranteed to be 1, which means this has to be 7 there. That means this can no longer be 7 here, so this cannot be the central circle, which means this is the central circle. So this must add up to 8. This is 1 and 7 adding up to 8. This must be 5, 2, and 1 adding up to 8 here. Therefore, this can't be 2 or 5. It's 4. That eliminates 4 here, so it's 5, which makes that 4. 4 eliminates 4 here, so that's 2. 8 eliminates 8 in the rest of the column, so it's 4. No 4 or 5 here, it's 8. No 2 or 4 here, it's 5. 4 eliminates 4 here. It can't be 7 because of 7 in the row. So this is 6, which makes this 4, which makes that 6, which makes that 9. And the rest of the digits will be just from normal Sudoku. This remaining digit here is 2. No more 2 here. 8 eliminates 8 here, so this is 5. 5 eliminates 5 here, so it's 8 and 5. This can't be 5 or 8, it's 7. No more 5 or 7 here, it's 8. That leaves 2 remaining in row 8, which has to be there because it can't be here because of 2 in the column, and 7. And that leaves 3 and 4 remaining, so that's 3, and that's 4. And that's the solution. Yeah, fairly straightforward. I was curious how these super fuzzy arrows would work. And I can see a lot of potential, actually, in that rule set. It's not that restrictive. It's just that it was restrictive in, well... It's restrictive the larger the line is, I should say. But you could have a lot of very short lines, right, that could do this. And that would be interesting to see. Yeah, pretty straightforward, I feel. It's probably between very easy and easy for me, but it's easy. It's a little bit more difficult enough that I would probably just classify it as easy. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.